All right, so here's the final video for the end of quarter turn-in. As you can see, I've got all the demos packaged up individually here. They get created on initialize. That'll load in all their files with the exception of the Beethoven async load. And then the update, all it has is the keyboard test, which activates each of the demos on the key press. I'll show those to you a little bit later. I'll put them all at the end of the video so you can skip if you'd rather run them yourself. But if we go to demo 1, you'll see that we've got all the creates, setting the pans, setting callbacks, playing with delays. All that is set up to run through the Audio Engine singleton that I have set up. That's the one that the game side owns. That is basically the API that the game coder would use for creating sounds. Sounds are then used to manage individual data of sound calls, I guess. The individual sound units that they're playing and setting pans and setting volumes and callbacks for. The Audio Engine itself also keeps track of priority. It has a linked list with a head and tail for active nodes, and when stuff gets stopped or removed, it moves it to an inactive list and manages the destruction from there. The Audio Engine also has a timer that I'm leveraging in kind of probably a bad way here, but for putting commands on the timer, if the user does something that they want to delay on, or if they want to specifically add a command, they just push it to the Audio Engine. That is updated in here, the Audio Engine update, and that just runs through the timer, ticks through, calls execute on any time events that need to be processed, and deletes them afterward. So all that's cleaned up in the engine. The engine is also the Audio Engine is also the keeper for the threads. So the Audio Engine start, called in the initialize function, will create and detach the audio thread. The audio thread itself launches the loading thread. Loading async is done through here. It'll push game to audio. The Audio Engine will create the buffer on the loading singleton, then tell the loading thread that tell the loading thread the location of that buffer to fill. So you'll see in the demo that async does work and works through the callback back into the game side. The audio thread takes care of all the Xaudio 2 stuff, basically. It still, unfortunately, has a big old switch statement for all the different kinds of things that can be sent over here, but I didn't get a chance to turn that into something more efficient. But as you'll see here, the call sounds do all of the Xaudio 2 work, setting up everything and starting sounds. Stop sound is pretty simple in here. In the Audio Engine, it's a little more complicated because I have to deal with the priority and managing the different lists that are handled on the game side for the game side sound calls. But now I guess I'm going to hop into actually running the code here. So if you don't care to watch the things on video, go ahead and stop now. I'm just going to end up hitting 1, 2, 3, 4, 5 all straight through. Alright, so I realized my demo 4 ended way early because I mistakenly put this end command far too early. So it's fixed in the code base and I can demonstrate it right here. Yeah, just hit number 4.